Hello children, we begin with exercise 5.5 question number 2. This is the figure given. You are given two quadrilaterals PQRS and MNRL, both are rectangles. M is the midpoint of the segment PR. Now you have to prove SL is equal to LR and also LN is equal to half of SQ. For the proof, you have angle PSR and angle MLR 90 degrees because they are angles of a rectangle and therefore it is 90 degrees. So consider SR to be the transversal, then they will be corresponding angles. Since they are congruent, it is proved that segment PS is parallel to segment LM or MN. Okay. Now, if I consider this triangle RPS, I have these two lines which are parallel to each other. M is the midpoint of PR. So according to the converse of midpoint theorem, I know that L will be the midpoint of SR. What is the converse of midpoint theorem? If in a triangle I have if a line is drawn from the midpoint of one side of a triangle and is parallel to the second side, it will bisect the third side. Therefore, ML will bisect the side SR. That means SL is equal to LR, or L is a midpoint of SR. So the first part of your question is clear. SL is equal to LR. Okay. Next, to prove the second part, we consider this angle PQR. Angle PQR is 90 degrees. Same reason, angle of a rectangle. Similarly, angle MNR is also 90 degrees. Okay. Now, these two angles are 90 degrees. And suppose I consider this to be the transversal. Then I have these two being the corresponding angles. You will get MN is parallel to PQ. Alright. Now, if MN is parallel to PQ, when I consider the triangle RPQ, M is the midpoint of the side PR. So, converse of midpoint theorem again, if a line is drawn from the midpoint of one side of a triangle and is parallel to the second side, it bisects the third side. So, I get Rn is equal to NQ, or N is the midpoint of RQ. Okay. Now, if I consider this triangle RSQ, I have L and N to be the midpoints of the sides RS and RQ. Right. So, by the midpoint theorem, LN will be parallel to SQ, LN will be half of SQ. What is midpoint theorem? If a line is drawn from the midpoint of one side of a triangle and it is connected to the midpoint of the other side, then that line is parallel to the third side and it is half of it. Right? So, LN is parallel to SQ, LN is half of SQ. So, I get the second part of the question. So, this is how it is to be proved. Okay? Both these parts. Next, I hope you have understood it, children. Next, we go to the third question, question number 3. This is the figure for it. You are given triangle ABC is an equilateral triangle. Points F, D, E are the midpoints of the sides AB, BC and CA respectively. You have to prove triangle FED also is an equilateral triangle. So, how is the proof? You are given AB, BC and CA are equal. FED are the midpoints. Okay. Now, since F and D are the midpoints of these two sides, FD is equal to half of AC. What is the reason? Midpoint theorem. Right. Same way DE is equal to half of AB. Same way FE is equal to half of BC. All due to midpoint theorem. But we know AB equal to BC equal to AC, and therefore even the half of those equal sides have to be equal, and therefore FE is equal to FD is equal to DE, and hence triangle FED or FDE is a equilateral triangle. So that's a very simple sum. I hope you have understood. We go to question number 4. This is the figure for question number 4, and what is given here in this question is segment PD is the median. Okay, segment PD is the median of triangle PQR. If PD is the median, it means QD is equal to DR. Point T is the midpoint of segment PD. you have to prove Pm upon Mr is equal to 1 by 3. Pm upon Mr is equal to 1 by 3. Okay. Now for construction, what we'll do is we will draw Dn which is parallel to Qm. Okay. And such a way that P dash, M dash, N dash are all these 4 points lie on a straight line. Now what you will do is you will consider this triangle PDN. T is the midpoint of this side PD. We know Tm is parallel to Dn. Okay. So from there, what do I infer by the converse of the midpoint theorem? You're drawing a line from the midpoint of one side. It is parallel to the second side. I know it bisects the third side. Therefore, I get Pm is equal to Mn. So when I write it like this, I've explained the proof here. Pm is equal to Mn. Write it as equation number 1. Now same method, you are going to consider this particular triangle, that is MQR. In this particular triangle MQR, again D is the midpoint of the side QR, Dn is parallel to QM. Therefore, what do I infer from here? That Dn will bisect the third side. This is the midpoint, it's parallel to the second side. Therefore, it will bisect the third side according to the converse of the midpoint theorem. Therefore, Mn is equal to Nr. This is what I get from the second equation. So, this is your second equation. Mn is equal to Nr. Consider all three. Pm equal to Mn, Mn equal to Nr. So, I can write Pm is equal to Mn equal to Nr. So, this length PR is equal to Pm plus Mn plus Nr, where all three of them are equal to each other. Pm plus Mn plus Nr. So since all three are equal, I can replace it with Pm itself. So PR is equal to 3 times Pm. This is 1 upon 3 comes to the denominator equal to Pm upon PR. So I get Pm upon PR is equal to 1 by 3. So this is the thing that needs to be proved in this question, which we have done it. Okay. So I hope children you have understood question numbers 2, 3 and 4 of this exercise. I'll be uploading the images of these 3 questions so you can go through it and understand it clearly. Okay. Thank you.